Hey everybody, how's everybody doing? We're gonna work on some geometry. I'm super tired today, so I feel draggy. So we're gonna work on some geometry. It's 10.5, section 10.5, and it's page 710. Okay, page 710, section 10.5. Hope everybody's doing well. Miss you guys. It's all quiet here. So that's that, I guess. Okay, so let's go to page 710. I feel like we've done this before earlier in the year, so this may be something that you're familiar with, but we'll go through it quickly. I don't think it will take us much time. Let's go ahead and start with example number 1. So in this section, what we're doing is we're describing changes that happen to shapes. So if I like double the side length of a rectangle, what would happen to the area of the rectangle? Or if the area tripled, what happened to the side? So it's just kind of a comparison of what happens to one thing when you do make a change to it, okay? And how it affects the area or the perimeter, okay? So let's look at example number 1. Okay, A, the height of the parallelogram is doubled, okay? So if I'm only doubling the height, that's not, so let's see, how do I say this? The basic thing to remember here is, did I change one part of the shape or two or all of the parts of the shape? Okay, so on A, I only changed one part of the shape. I only changed the height. So the height of the parallelogram is doubled. So remember, on a parallelogram, to get the area, it's base times height. So let's look at example A. They did 12 times 9, and they see it's 108 for the area of that parallelogram. Now they say that the height is doubled. So instead of 9, it'll be 18. So let's see what happens to that. 12 times 18, you can say there, C, on the right-hand side, is 216. So what they've showed is that the area also doubled, okay? So the rule for this kind of shape is if one thing changes, in this case it was just the height, if one thing only changes, the area has the same change. So if the height is doubled and it's only the height that gets doubled, the height will be doubled and the area will also be doubled then. It's exactly the same change that happens to both of them, okay? So again, if one thing changes, and you can take a screenshot of this if you want, these are gonna be our little helpful hints today. If one thing changes, the area has the exact same change. Okay, so let's look at B. The base of the triangle, it gives the vertices there, and it's multiplied by 1/2. So the base is cut in half, okay? Which means only one thing changed, right? Just the base, not the base and the height. So since only one thing changed, the change in the area is the same. So if the base got decreased by 1/2, the area will also decrease by 1/2. It's the same change, okay? All right, so check it out, number 1 on the bottom of page 710. If the height of the rectangle is tripled, so it's just the height, it's not the base and the height, it's just one change, the area is also tripled. And you can just write as the answer, what would happen to the area? It would be tripled, okay? Example 2 is when we move on to having two things change or all of the parts of the figure change. Like if I have a rectangle, it would be the base times the height. If those both changed is what we're talking about now, okay? I put two things here. It also is all because in a circle, the change in the size of the radius is everything that can be changed about the circle. So it would also fall into this category with the purple, okay? Circles and two parts of a shape, okay? So if we're doing two parts of a shape, like example 2A, the base and the height of the rectangle both changed. Okay, if the base and the height both changed, the area has the same change but squared. Okay, so let's look at example 2A. The base and the height of the rectangle are 8 and 3, and we get an area of 24. Then it says they're both multiplied by 5. So now they would become 40 and 15. Okay, and notice when they become 40 and 15, the area becomes 600. So the change between 24 and 600 is actually 25. So if we have a change of both parts of the rectangle and it's increased by, multiplied by 5, the change in the area is whatever that change is squared. So the area would increase by 25 times. Okay, so if the base and the height change get multiplied by 5, the area multiplies or increases by 25. Okay, so we square whatever the change is. I put change squared here so you would know. Okay, so then for circles on B, the radius is multiplied by 1/3. Now, don't get confused. I know there's only one thing that changed, but the radius is the only thing we can change on a circle. So it falls into this category down here, okay? If the radius is changed by 1/3, we take that change and we square it to figure out what the area does. So if the radius changes by 1/3, square that, the area would change by 1/9. Okay? All right. So the same can be done backwards. If I know the change in the area is 1/9, to figure out the change in the radius, I just square root the area's change. Okay? And that's what they're showing you on example number 3. The square has a side length of 5. The area got tripled. What happens to the side lengths? So the area is tripled. So that was times 3. So to work backwards to figure out what happened to the side length, instead of squaring, we do the opposite, which is square root. So if they give you what the area did and you have to work backwards to get the side, just square root the area change. Work backwards and that will give you the side change, okay? And that's so if it's tripled, like it says here, the area is tripled, the side would change by the square root of 3, which is, you can see what they got there in example 3. It's just working backwards from this, okay? Okay, I think that's it for today. So you're basically gonna do a lot of telling me it tripled, it multiplied by 9, the side changed by the square root of 2. So you're just telling me the changes that happen. You're not actually giving me the actual new answers. You're just telling me the change that occurs from one to the other, okay? So that's all we're doing today. It should be hopefully not terrible, but sometimes it gets a little confusing. So call me and let me know if you have any questions. And our question for today is, a round pastry has a radius of 2. When the radius was doubled, what did the circumference do? It ate pi. You're gonna have to think about that one for a minute. A round pastry has a radius of 2. And when it was doubled, what did the circumference do? It ate pi. I'll let you process that. See ya.